In this video, we're going to look at isotopes and the atomic mass of different elements and atoms. So hopefully as a review, the atomic number of an element is the number of protons in the nucleus of each atom of that element. If the number of protons were to change, that means that the element has also changed. So if we look at the periodic table and we look for tin, we can see that tin, the atomic number here is 50. And so, it's right here is 50. So the atomic number of tin is actually 50. So that means that tin has 50 protons. So then too, if we look for potassium, potassium is over here with element 19, and we look for the whole number. So it tells us that our atomic number is 19. So that tells us that there are 19 protons in potassium. The mass number refers to the total number of protons and neutrons in an atom. So we are looking for the mass number of gold, and so we can look at gold on our periodic table, and we can see that gold is right here, Au, and so it has an atomic number, the whole number, of 79, and it has an atomic mass of 196.97, and we get that from this decimal number right here. So then the question further asks us, what is the mass number? And so in order to calculate the mass number, sometimes we have to round our atomic mass number because we can't use decimals. So this would round up to 197. So we take our atomic mass, so the 197, minus our 79 protons, and we would get that there would be, carry the 118 neutrons in gold. So same process for zinc. It's wondering how many neutrons. So we need to find its atomic number and its atomic mass. So we can pull up the periodic table and find zinc. And here we have zinc. Its atomic number is 30. So that tells us how many protons there are. And the atomic mass is 65.38, which would round to 65. So to figure out the number of neutrons, we would take 65 minus the 30 protons, and we would get 35 neutrons. The atomic mass is reported in a unit called the atomic mass unit, and you can definitely abbreviate it AMU. And this is the mass equal to 1/12 the mass of a carbon-12 atom. So there are a couple different ways to write this atom or write this information for each atom. And so this method right here is called the nuclide notation. And with the nuclide notation, the mass number is written on top, and the atomic number is written down below. with this other method over here on the right hand side, the only piece of information that we're given is the mass number. So generally speaking, the nuclide notation gives you a little bit more information because it does give you that atomic number, whereas the second notation, I don't know if it has a special name or not, it just gives you the mass number. So isotopes refer to atoms that have the same number of protons, but they have a different number of neutrons. So for example, carbon has 3 isotopes. We call them carbon-12, carbon-13, and carbon-14. And those numbers are referring to the mass number. So you can see that the masses increase by 1 with each isotope. These are naturally occurring samples. And most of the time when we grab a sample of carbon from nature, there will be a mixture of isotopes. So in carbon-12, we know that carbon's atomic number is 6. So a way to write that would be the nuclide notation with carbon like that. And so in carbon-12, there are 6 protons and 6 neutrons. 6 plus 6 gives us 12. In carbon-13, it still has to have 6 protons, otherwise it wouldn't be carbon, but now it's going to have 7 neutrons. 7 plus 6 gives us the 13. In the last one, carbon-14, again, still maintains 6 protons, but now it's going to have 8 neutrons. So when you look at the periodic table, it reports carbon's mass as 12.011 AMU. And this is based off the average mass of all carbon's isotopes. So when we look at the reactivity of an atom, chemical reactivity is not affected by the presence or absence of isotopes. Rather, chemical reactivity is due to the presence of protons and electrons. And so a nuclide is the nucleus of a given isotope of an atom or of an element. So right here is the nuclide information about carbon-12. So if we practice, how many protons, neutrons, and electrons are present in each nuclide? So we're going to have to do a little math. And so for iron, we know that this number here is our atomic number. And the top number is our mass number. And so if we want to know the protons, we look at the atomic number, so we know there's 26. To figure out neutrons, you subtract 56 minus 26 to get 30 neutrons. And then for electrons, the number of electrons will always equal the number of protons because atoms are electrically neutral. So you have to have the positive charges balance out the negative charges. Iodine 27 or 127 only gives us here the mass number. So that will require you to look up iodine on the periodic table, and it's over on the right hand side in that halogen family. And you can see that iodine has an atomic number of 53, and its mass number was told us is 127. So from here, we can go ahead and say, all right, the number of protons is 53. Our number of neutrons will be 127 minus 53, so 474. And lastly, our number of electrons will equal the number of protons. So for the last example, we have phosphorus. We got it given to us in nuclide notation, so we have enough information and don't need the periodic table. And so the number of protons would be 15, corresponding to the atomic number. And then our number of neutrons would be the 31 minus 15 for 16 neutrons. And lastly, the electrons, again, has to match the protons because the atoms are electrically neutral. So to calculate the average atomic mass of chlorine, it's going to be based off of the following information. So we have two isotopes of chlorine, chlorine 35 and chlorine 37. And so if we have chlorine 35, its atomic mass is 34.969 AMU, and it has a percent abundance of 75.77%. So that means if we take all the chlorine in the world, 75.77% of that chlorine will be chlorine 35. Likewise, if we look at chlorine 37, its atomic mass, it's a little bit heavier, which makes sense because it's got a couple more neutrons, is 36.966 AMU, and its percent abundance is 24.23%. And so, again, if you took all of your chlorine worldwide, 24.23% of it would be the isotope chlorine 37. So, in order to calculate our average atomic mass, or this would be the number on the periodic table that shows us mass, we need to do a little math. So to do this, you take your atomic mass for the isotope, so 34.696, and you multiply it by its percent, but you have to take it out of percent form, and it needs to be as a decimal. And when you do that, you'll get 26.496. And then repeat that process with chlorine 37, so 36.966 times its percentage. But remember, you have to put it in decimal form. And you get 8.95686. And then the last step is to add your two numbers together. So 26.496 plus 8.95686, and you would come up with 35.45 AMU as chlorine's average atomic mass. If you were to look at chlorine on the periodic table, you would see that this is indeed chlorine's average atomic mass.